So boys and girls, in this video we are going to talk about what is meant by thermal expansion. Okay, so thermal expansion is referred to a change in the dimensions of a body accompanied by a change in temperature. It means that when there is a temperature change, we find out that the dimensions of a body change. What is dimensions? What we mean by dimensions? Dimensions of a body means actually it refers to the length, the area, or the volume. Okay, that one we call it as dimensions of a body. So we found that most of material might expand when heated and contract when cool. So maksudnya kebanyakan material kita dapati bila kita panaskan, benda tu akan mengembang, dan bila material tu disejukkan, dia akan mengecut. Saiz dia jadi lebih kecil bila sejuk, dan bila dipanaskan, area dia mungkin jadi lebih besar, ataupun kalau dia ialah satu rod, dia akan jadi memanjang. Okay, that one we call thermal expansion. So class, normally for solid, we might have linear expansion in form of length, or area expansion and volume expansion. Anyhow, for liquid and gas, normally liquid and gas, they do not have fixed shape. Dia tak ada bentuk yang tetap kan. Normally untuk liquid dan gas, mereka akan mengambil shape container yang simpankan liquid dan gas. So normally untuk liquid dan gas, we only have volume expansion. Okay, so for liquid and gas, we doesn't have linear expansion, we doesn't have area expansion, because liquid and gas doesn't have fixed shape. Dia tak ada bentuk yang tetap, tapi bentuk liquid dan gas adalah mengikut bekas yang simpankan liquid dan gas tu. Okay, jelas Class, let us consider linear expansion. So let's say I have a rod. Initial length is L0. Then the initial temperature of the rod is 25 degrees Celsius. Then I heat up the rod. So I heat up to a final temperature of 100 degrees Celsius, for example. So what happened to the rod? You will find out that the rod will expand. So rod ni akan memanjang. Okay, dia akan memanjang. So after we heat up to 100 degrees Celsius, you might find out that the rod become longer and the final length is L. The final length is L. So we can see very obviously there is a change in the length. So the change in the length, the increase in length when the rod is being heated to a certain temperature, when the temperature increase, we call it as delta L. Delta L is the change in length. Okay, when there is a change in temperature. This is the equation we use to find the change in the length when there is a change in temperature. Okay, what is alpha? Alpha in the equation refer to the coefficients of linear expansion. Different material, they have different coefficients of linear expansion. Okay, so the value of coefficient of linear expansion, it depends on the material. So coefficient of linear expansion for aluminium, it won't be equal to the coefficient of linear expansion for copper, for example, they are different. Okay, they are different. So how we find the final length? So you can see very obvious from the diagram. The final length is the initial length plus with the change in the length due to the change in temperature. So L final will be L naught plus delta L. So delta L is this equation. So kalau teacher masukkan delta L dengan nilai alpha L naught delta T, dan saya boleh dapat equation yang ketiga ni lah. Okay, equation yang ketiga ni. Okay, so alpha, the unit for alpha, how we define alpha? Alpha is the fractional change in the length per degree change in temperature. Okay, so the unit for alpha can be in Kelvin minus 1 or degree Celsius minus 1. It doesn't matter. Then we move on. We might also have area expansion when we heat up a piece of aluminium, for example. If we heat up a piece of aluminium, we find out that the area will expand. The area will expand due to the temperature change. Okay, area dia akan, luas permukaan tu akan bertambah bila temperature kita naik. Okay, so if we assume the initial area as A naught, change in area as delta A is the final area, delta T is the change in temperature. So bear in mind, change in temperature must be the final temperature minus the initial temperature. So how we find the change in area? So the change in area equal to beta A naught delta T. Beta is what? Beta is the coefficients of area expansion. So how we define beta is the fractional change in area per degree change in temperature. So the unit is the same as alpha, Kelvin minus 1 or degree Celsius minus 1. Okay, so how we find the final area? The final area must be the initial area we have plus with the change in the area. Change in the area. Okay, so if you put the beta A naught delta T into this delta A, you will get the third equation lah. So final area will be the A naught initial area in bracket 1 plus beta delta T. Okay, that one is area expansion. So coefficient of area expansion, we can relate with the coefficient of linear expansion. Beta, coefficient of area expansion, is 2 times of coefficient of linear expansion. 2 kali. Kenapa 2 kali? Sebab kalau area kembang, dia ada length, dia ada length, dia ada width. So dia ada 2 kali linear expansion. So that's why area expansion, coefficient of area expansion adalah 2 kali coefficient of linear expansion. Okay. Then we have the third one, volume expansion. So for example, we have a cube. We have a cube of initial volume V0. We have a cube of initial volume V0. Then we heat up. Kita panaskan cube ni, so what happen? The cube will expand. Dia akan expand. So we assume the change in volume is delta V and the final volume is V. The change in temperature is T final minus T initial. So change in volume is given by gamma V0 delta T. What is gamma in the equation? The gamma represents the coefficient of volume expansion. So how we define gamma? Fractional change in volume per degree change in temperature. Kelvin minus 1 or degrees Celsius minus 1. So the three coefficient of expansion have the same unit, Kelvin minus 1 or degrees Celsius minus 1. Okay, so how we find the final volume? Final volume must be the initial volume plus with the change in the volume. So the change in the volume is this equation, so we substitute in, we can get the third equation lah. The final volume will be the initial volume in bracket 1 plus gamma delta T. Okay, so class, we can relate the coefficient of volume expansion with the coefficient of linear expansion. So kalau you perhatikan, untuk volume cube ni expand, dia punya length akan expand pada waktu yang sama, dia punya tinggi akan expand, dia punya lebar pun akan expand. So untuk volume, dia melibatkan 3 kali linear expansion. That's why our coefficient of volume expansion is 3 times of coefficient of linear expansion. 3 kali. So class, we might have linear expansion, area expansion, and volume expansion. Okay, so which equation we need to use? It depends lah. We want to determine the change in length or change in area or change in volume. Alright, okay. So guys, now let us consider a special case whereby we have expansion of liquid in container. Okay, so boys and girls, kalau you perhatikan, kalau kita nak panaskan liquid, kita mesti letakkan liquid dalam container. You tak pernah panaskan air semata-mata, betul? Kalau you nak panaskan air, mestilah you letakkan air tu dalam bekas. Lepas tu you panaskan sekali dengan bekas dia, container dia. So, for expansion of liquid is usually measured in a container. We cannot just heat up the liquid alone. We must put the liquid in a container, then only we can heat the liquid. Okay, so when a liquid expand in a container, we will find out that actually the container will expand along with the liquid. You simpan liquid cecair dalam bekas, so you panaskan dua-dua benda ni. So kalau you panaskan dua-dua benda ni, bila you panaskan, bekas dia akan kembang, liquid dalam bekas pun akan ikut kembang. So normally we will find out that the coefficients of volume expansion for liquid is much more greater than coefficient of volume expansion for solid. The solid here refer to the container. The solid here refer to the container. Bekas kan? Bekas adalah solid. So liquid expand much more than the container. So kalau liquid dalam container kita dia mengembang dengan lebih banyak, maksudnya the liquid will spill out or overflow from the container. So class, the volume of overflow, or we call apparent expansion, is equal to the difference between the value of change of volume for liquid and also container. So this is the equation we find the apparent expansion, or we want to find how much of the liquid is being overflow. So how we find the liquid that overflow from a container? When we heat the liquid in a container, we take the change in volume for the liquid minus the change in the volume for the container. Okay, this is how we find the volume of overflow, or we call apparent expansion. So boys and girls, actually how thermal expansion occurs? When we raise up the temperature or we heat up a material, how come the material will expand? So actually, when the temperature is rise, it will cause the molecule to be active in motion, and they will push the adjacent molecule to the side. So bila dia tolak ini molekul dia akan vibrate. So bila kita naikkan suhu, dia jadi makin panas, so dia akan vibrate dengan ke kiri dan kanan dengan mengambil ruang yang lebih besar. So dia akan menolak kawan ataupun molekul di bersebelahan dia ke tepi. So this will cause the material to expand. So ini menyebabkan benda tu akan mengembang lah kalau dia panas.